When fire starts in an informal settlement or a managed or unmanaged humanitarian setting, it has the potential to spread from one shelter to the next. Often, this can cascade into fires where hundreds of homes are burned to the ground and their inhabitants made homeless. The use of combustible building materials and the dense layout of settlements makes it easy for fires to spread, but there remains little in the way of quantitative data to help address the fire spread problem in a practical way. Where guidance does exist, it is often specific to a certain context, or it applies a one-size-fits-all approach to a complex problem that does not reflect the variety of different materials and styles of shelters that exist in reality. In 2024, in the Western Cape of South Africa, Kindling set out on an experimental program aimed at understanding the impact of different shelter materials on the fire hazards posed by a burning shelter. By testing shelters made from timber, mud, bamboo, thatch, sheet metal, and more, our aim is to provide contextualized understanding of the different shelter materials and the role they play in fire spread in real settlements. This series of videos tells the story of those experiments.
Oh, some nice flames outside there. There's flames this side, the facade's going on the outside.
To understand fire spread between shelters, we must first understand three important aspects of fire spread risk: hazard, exposure, and vulnerability. If we think about fire spread from one shelter to the next, we can think of the hazard as being the nature of the burning shelter that could cause it to spread fire. That could be the amount of heat it is releasing or the flames it projects towards its surroundings. We can think of the exposure as how close the neighboring shelter is. And we can think of the vulnerability as the properties of an exposed shelter that make it susceptible to ignition. Usually, this is mostly as a result of whatever the material it is made from, since different materials can be easier or more difficult to ignite. The experiments that we cover in these videos exclusively aim to understand the hazard, namely how a single shelter burns and the resultant ways it might be able to spread fire to its surroundings.
Shelter, that's not good, that's not good. Yeah, it could be worse. Yep, it's gone down.
In this first video, we show how we set up one of our experiments ready to be burned, and the variety of instrumentation that we used to capture key data. In each experiment, we burned a single mock shelter. Each shelter is more or less the same, with the same floor area, a door in the front wall, and a window in the back. The only change made across each experiment is the material which the shelter is made of. The purpose of the experiment is not only to visually demonstrate how the fire behaves, but to measure and to quantify it to help us understand how it might ignite any neighbouring shelters. To do this, we use a variety of instrumentation to capture different physical properties of the fire. We want to understand many things, such as the rate at which the fire is releasing heat, the size and direction of flames projecting from the shelter, and the heat exposure all around the shelter in all directions. Firstly, the entire shelter is built on a 6-ton capacity scale, so that its mass can be measured. Despite the logistical challenge of sourcing and installing the scale, it was an essential piece of equipment because of what we could learn about how much energy is being released by the fire. Specifically, the scales measured the mass of the shelter. The rate at which the shelter loses mass during a burn is proportional to the amount of thermal energy that the fire releases. This is the heat release rate, an important metric for indicating the size and intensity of the fire. Inside the shelter, we installed a number of thermocouples. These are simple devices which measure the gas temperature inside the shelter as the burn progresses, and they help us to understand how the fire grows and changes over time. Outside the shelter, we are interested in learning about the heat exposure to the surroundings, which can help us to understand how quickly any nearby combustible materials will ignite. To do this, we use two different types of device that measure heat flux, the rate of thermal energy transfer per unit area. The first and more accurate of these is called a water-cooled heat flux gauge. We placed two in our setup. one each at 2 meters away from the window and door of the shelter at 2 meters height, equivalent to the height of the top of those openings. The second type of device is called a thin-skin calorimeter. Although these are less accurate, they are much less expensive and are easy to make, so are useful for using when high numbers of heat flux measurements are needed. For these experiments, we placed 60 of these around the shelter, 30 each at heights of 2 and 2.4 meters, and spaced at distances of 1, 2, and 3 meters away from the shelter. As a crucial driver of fire spread, we measure the wind conditions in each test. 3 anemometers measure wind speed, 2 are located 10 meters directly in front of each of the door and window. 1, around 20 meters from the shelter, is placed in what we call the far field, outside of the potential influence of the burning shelter, with this one accompanied by a weather vane to measure the wind direction. All are positioned at a height of 3.5 meters above the ground. Finally, we place 3 cameras to capture the characteristics of any flames emitted from the shelter. 2 are positioned to face directly along each of the door and window walls to view the length and height of flames projected from those openings. A 3rd camera is placed in front of the shelter, looking through the door to observe the growth of the fire inside, as well as if the walls or roof burn. Footage from the cameras is important for understanding the extent of the area around the shelter in which neighbouring shelters might experience direct flame contact. Fire experiments of shelters must take account of the items found in the shelter as well as the shelter itself, as these are often where much of the energy that the fire releases as heat is initially found. To represent the belongings and furniture that compose the fuel load in real shelters, we use 2 wood cribs on which the fire is initially set. While these don't look like a real fuel load, they are frequently used in fire experiments as a well quantified and repeatable substitute for real fire loads, and they're designed to represent an equivalent total amount of thermal energy to be released during the fire as in real shelters. Using them, we can be confident that in each experiment we are exposing every new shelter to as similar an internal fire as possible to all other experiments. The wood cribs are ignited by lighting up 8 small packets of hessian soaked in paraffin at the start of the experiment. So this is how we set up the experiments with the aim of understanding the ways in which a burning shelter may be able to spread fire to its surrounding, or its fire spread hazard.
It's a very different burn than we normally see in low wind conditions.
Oh, that's nice. That's nice. That's nice.
Watch the next video in our series that show the results of some of our experiments. We explain how shelters of different combinations of materials burn, the unique challenges of thatch-style materials, and the impacts of wind. In our final video, we will discuss how technical findings of robust experiments may contribute to developing guidance for approaches to fire safety.